Hi everybody, my name is Khairul Abror. I am a graduate student of Forestry Faculty, University of Gadjah Mada, Yogyakarta. Today, I'm going to share you some of informations about how to screen the trees which is resistant to wind. This method is very useful for forest plantations. Wind is the nature phenomena which have a lot of benefits. Now I'm going to share with you the top 5 of benefits of the wind. On the other hand, the wind also make damage to us. The following video will show you how is the wind force can destroy anything what we have.
Yeah, oh, the Hati. Oh, oh.
Sedih ni. Sedih ni.
Ako si Ini. Oni!
Vem är en junge? Ja, inte så bra.
That's got to be the best part I've ever seen. So it will seem.
En nog een. Nou, nummer 3.
I have shared to you the advantage and the disadvantage of the wind. Now, before we go or discuss further about this method, I want you to do a favor for me. Please subscribe to this video, then you can follow any update from my channel. In previous video, we have seen a wind damage occur outside of forest plantations. Now, I'm going to share you what will gonna happen if the wind damage occur inside a forest plantations area. I am forestry private company employee. I've been working in this company since 2006. And I'm working in the tree improvement, research and development department. I've said in the previously that this method is very useful for a forest industry company. Based on our inventory, especially in the last 5 years, we found that there are average 14% of the area affected by wind. So these amounts of area is very huge, very huge. Of course, if we do not do something related with this issue, we will have a big problem. So the idea is, how do we perform a certain test, a certain method to screen the trees or the clones which is resistant to the wind damage? Means that these trees is resistant when the wind blow to the certains of area and keep the trees alive. Means that this area still have full stocking of trees. Now, how do we test, how do we perform this method? We are using a split plot method in this research. We use four of our operational clones, and then we test in two different slopes of area. The first is, of course, the flat area, and the second is the steep area. So the slope and the steep area. We want to see what happened in both of sides. And then for the replications, we use three different sites for the replications. Now, how do we select the trees? How do we select the trees for this test? Of course, once you determine the locations for this test, you need to make a plot. In this case, we can use 10 trees by 10 trees, and then inside this plot you can select 5 trees to be tested. Of course, the trees should be healthy, no defect, of course, no pest and disease infections, so that we are assured that we select a good trees. Good trees means that there is no signs of defect, so that we hope that we can evaluate the strength of the trees when the winds blow. This is the wind tolerance scheme. This is how we do the tests in the field. As you can see from this scheme, that our selected trees here in the left side tied up with the rope in average 70 to 80% of the total height of the trees, and then the rope connect to the pulley, and then connect again. Here we put the dynamometer, and then end up with the portable winch. So with this scheme, the selected trees will be pulled by using the winch, the portable winch, and then the trees will form a certain degrees of positions, and during the test, this dynamometer will record how much is the force to force the trees become leaning. And then the pulling process keep going until the trees is break. End of the process, we can get the data from the dynamometer, and then we can compare between trees. The trees which has a high force means that these trees is more resistance from the other trees. It means that it needs bigger force to break the trees. In this video, in these slides, I'm going to tell you about the two main equipment which use to measure the wind resistance trees. The first equipment is the dynamometer. This equipment will record the energy which is measured in kilogram force during the test, from the beginning until the end. And also, this dynamometer can record in specific time when the trees is broken. The second equipment is the portable winch. This winch is very compact, very easy to carry, so that you can move from one point to another point without any problem. This is how we measure, how we determine the tree positions during the tree pulling method. When the tree is pulled by the portable winch, and then when it reaches the 30 degrees of positions, then we take a look at the dynamometer data, which tell us how much is the force to pull the trees to reach the 30 degrees of positions. Then the pulling process continue to 45 degrees, 60 degrees, and even the trees is break. In each of the positions, we record how many force, how big is the force to describe, to figure out the force on each tree positions. So these numbers can be compared between trees to find out what trees has a big force. Now you can see how we make the wind resistance test. This view taken from the side. And now you can see the view of tree pulling method from the front.
patah kayaknya.
Tahu tuh.
Ini patah. Bandel kan dari akarnya. Geser.
There are three categories of result from this method related with tree pulling. The first category is the trees which is break when the tree was pulled. The second category is the tree which is leaning. Leaning means that when the tree is pulled and the canopy touch the ground and it doesn't break. We call it as a leaning. And the third, the tree is fallen. So this is the tree and then pull down and it fallens, starting from the bottom, from the root, fallens or uprooted. So these three categories can be recorded, the process, during the process, the whole process, by using the dynamometer. So when the trees is break, the dynamometer can show us exactly in what second the trees is break and which how many forces to break the trees. That is the first category. The second category, the trees leaning. The dynamometer also can tell us in what second the trees is leaning. The canopy touch the ground. In what second? And in how much force needs to make the trees is leaning, touch the ground. The canopy touch the ground. And then the third, the dynamometer also can determine in what second the trees starting to step by step or slow but sure fallen, touch the ground. So that is the advantage of this equipment. By using the dynamometer, we can record. We know exactly in what second and how much is the force do we need to break the trees or to lean the trees. From this data, we can compare each of the trees. We can compare the force among the trees. Then we can select what trees is more resistant to wind. So we can say that the winds is represents by the pulling method. The pulling method. So by pulling the trees, we can create a constant force to break the trees or to change the positions of the trees to make it break. That is the objectives of this tree pulling method. And then after that, after we can compare, we can determine which trees is the good trees. The good trees means that the trees which needs a big force to break the trees. Then these trees or clones can move to the next process. But before that step execute, from this data, from this trial data, we can compare with wood properties data. Of course, once the trees from all of these trees in this method has been tested fallen, break, or whatever it is, then we can take the samples of the wood samples from these trees. These samples then we analyze for the wood properties data, such as basic density, the fiber dimensions, the wood anatomy, specific gravity. All of these informations can combine and compare and see the relationships between the wood properties data and then these dynamometer data. We can see the correlations. If the correlation shows a good correlations, means that we don't even need to take the wood samples to perform this wind tolerant test. We only take we can perform this pooling trees method by pooling the trees and then record and take the numbers, compare the numbers. Then we know that if the data shows good correlations. But what about if it is not shows the good correlations? Well, something wrong, needs to be checked again. So as a conclusions, this is my research topic for my thesis. By using this method, we can perform tree selections which is resistance to winds. So guys, if you have any idea, any suggestions related with this method, I'm happy to hear that, so that we can improve this method, become better and better in the future. So I think that's all for now. Thank you very much for your attention. See you next time.